Hi, we're Maddie and Nico, and we are turning this empty cargo van into this tiny home on wheels. We have no building experience, but we'll take you along each step as we transform our 2020 Ford Transit van.
Hello YouTube, welcome to our electrical part 2 video. Today we are installing our Renogy 3000 watt inverter charger and all of our 120 outlets and shore power inlet.
We chose this Renogy inverter charger so that way we could not only have 120 volt power in our van, but we could also charge our van off of shore power if need be. This will be in addition to our solar powered charging and our DC to DC charging off the alternator.
So without further ado, we're going to start off with the shore power inlet.
All right, so part of our wiring setup is to install shore power. So we're going to set up a 30 amp shore power inlet. This will allow us to charge our batteries if we're plugged into RV hookups or if we're just parked outside of like a friend's house and we want to borrow some of their electricity. We can just plug it in and charge up our batteries. For the most part, we're gonna rely on solar or our alternator to charge our batteries, but in the winter time, we'll probably have a few days where we're just not getting enough sun or we're not driving around enough. So it's good to have shore power for this reason. So I'm gonna get started on hooking this up. I'm gonna wire our 10 gauge 3 conductor wire to our 30 amp shore inlet. So first what I'm gonna do is take off this little inlet cover off. This thing is from the back of our 30 amp inlet. So I'll take off this cover and we're gonna feed the wire through there. The wire is gonna go back through this hole and out the front. I'm gonna take a couple inches of the sheathing off of this wire. I just have normal wire cutters. I'm gonna kind of like cut into it and then use like a box knife, but there are special tools that you can get that make stripping this kind of wire much easier. And once you have the outer sheathing off, we just need to strip these down, probably about 3/4 of an inch. Okay, so now on the back of this, I just need to undo these screws. There are 3 of them and they retain the wires in these holes. So I'll undo those next. You're gonna insert the wires into the color coordinated holes and then you're gonna screw those screws back down. Then you just wanna pull on your wires a little bit and make sure they're solidly connected. Okay, once all your wires are good, there's no insulation in the way of your connection, you're gonna slide this guy back up and screw it back into place. Okay, so I'm gonna reattach this. Okay, so now we're gonna go to the van to where we're actually going to install the inlet, and we're kind of doing like a hidden under the van thing, so I'll show you where that is. So these 2 plastic covers under here, and I believe if you take them off, you can get to the inside of the van. So you're gonna have to use the rectangle one, not the square one, because the square one is just slightly too small. I mean, you could cut it a little bit to make it bigger, but there's a rectangle shaped one right next to it, so. So yeah, from down there, the wire comes up into this side column where I'm just gonna route it back into this wall to come out to our inverter, which is right here. So it's a new day, and that's because we needed to order a 3-inch hole saw, which we now have acquired, and we are going to cut a hole in this rubber thing that was under the Ford Transit, and then put our shore power inlet into that. After drilling the hole, we decided the rubber cover needed to be reinforced in order to support the shore power inlet. We used a scrap piece of plywood left over from our walls and glued it to the back of the rubber cover. So now we are screwing our shore power inlet to the plastic thing with the wood backing. It's nice. I was worried that it would be too hard to like open it and that it would pull too much on this plastic, but the the rubber plug is like, it's pretty solid on there. Then we pulled the wire up from the back pillar and routed it to where we wanted it to go. Shore power inlet.
Here we got big boy.
Big boy.
Oh, he's about 60 pounds.
Not as heavy as Lucy. You're 60 pounds. We cut 2 pieces of equal length positive and negative 2-aught wire and attached them to these terminals on our inverter. When attaching these wires, the order is wire lug, washer, lock washer, then nut. Then we fed the cables through the inverter plate and attached them to the negative and positive terminals on the Lynx power in. We attached all the washers and nuts in the same order as the other side and later added a 200 amp fuse under the positive wire lug.
I guess we need a fuse on there, but
we will
get that later.
Use it later before we turn it on.
Grounding to the far end of our Lynx.
We use an 8-gauge wire to ground the inverter as per the manual. This far terminal on the Lynx has no place for a fuse, so it's perfect for this ground wire.
I'm hooking up the ground, which is this tiny little guy back in here. Take your nut driver. Voila.
Wow.
Grounded. This will be our 120 loads. So Maddie stripped back these.
These are called ferrules and they get crimped onto the end of your wires to make them easier to input into your terminals without the wire strands getting frayed. There's a special crimping tool you'll need to add these.
Voila. Now that I got my ferrules on, my wire stripped back, I'm going to seal this up with some heat shrink.
The shore power inlet goes through the bottom entry gland on the inverter, and the line out to the 120 volt loads goes into the top entry gland. We found it easiest to start at the bottom entry gland and use needle nose pliers to pull the wires into their respective terminals while screwing them in place. Just so there's no confusion, this is how we wire up the inverter charger. It'll tell you here, ground, live, neutral, neutral, live, ground. So we have ground, live is black, neutral is white, neutral is white, live is black, green is ground. Now the wire from the inverter switch, which we pre-wired previously, is run through the black wire entry gland and it connects to the RJ11 port. Then we screwed everything back into place and screwed the inverter into the wall. So for our 120 outlets, I got this small breaker box. So we only have 2 breakers that we need to house in here. So this is the smallest thing I could find, which is still, it's a pretty hefty thing, but it's fine. So anyways, inside there are just these 2 places for the breakers, and it comes with this one negative bus bar in here. It's kind of weird, you have to get your ground bus bar separate. So I've put a link to both of those. But here is the grounding bus bar, which I will put in here. It's just this little hole down there that'll screw right into. So I'm gonna do that. There we have it. So Nico went ahead and knocked out few of these holes. I'm putting a grommet on the 2 holes. So I'll put one there, and I'll put one there for our wires to go into this stupid little box. All right, here's where I mounted the box. Pretty much just did a screw up here and there just because we didn't have anything to screw into really besides the wall on this side. There is also some Velcro behind this, some like industrial strength Velcro, so it just doesn't wiggle if it was going to, but I think honestly these 2 screws are fine enough. So now I'm going to put our wires in and start wiring them up. Okay, so now I have from our inverter, this wire here, coming up to feed power into this electrical box is where the positive, the live wire comes in, but they are not connected to each other, so I need to make a little jumper wire, which I've seen a couple people do. These are normally meant for a house, but it's a lot smaller and a lot less expensive than some of these big distribution panels, and since we just have 2 circuits for outlets, I just figured we didn't need to get the huge expensive thing with many more locations for breakers. But if you need a lot more breakers for your AC loads, then there are totally other RV distribution panels out there that have a lot more breakers. So anyways, here's this. So this is white, which is our neutral, our live wire, which is positive live wire, and then green is our ground, which just goes to that bar there. Now I will bring in our branch circuits, which will come in through this top grommet. So now I have everything wired up here. We already talked about this is the power coming into the box, and then these are our branch circuits, one for either side of the van. We have both of the neutral wires coming here. The live positive wires are going into these, and the ground wire is going down here. So the last thing I need to do before being done is just make a bridge to bridge these 2, so that way both circuits can be powered and not just this one. Also, you will notice this is upside down, so these are off right now, and we'll flip them that way to be on. It just worked out better to mount it that way. And here's the final wiring. There's this loop I've added here. Gave everything a nice tug to make sure that it's all connected well. Okay, there it is. Got the cover on. So right now I am going to be wiring up a few of our 120 volt outlets. To do that, I've got a blue electrical box. I've got an outlet, wire cutters and strippers, box knife, which is my method of stripping the outer coat on these wires. And here's my outlet that I'm working on. When we pre-wired, we just ran 14 gauge extension cord. The insulation around extension cord isn't as good as like marine grade wire. You definitely want your wire to be stranded. So we do have stranded copper wire here inside the extension cord. The only difference between extension cord wire and then the nice marine grade stuff would be the outer insulation. So I think this should last fine, but technically the other wire, the marine grade wire, would be better. But here, we're gonna go ahead and strip some of this back and start getting it hooked up. And we have our wires here. I will be wiring the outlets on either side of our van in parallel. This one is the last outlet on the run, so we can directly connect these wires to this outlet since we won't be daisy chaining off to another outlet afterwards. The green wire I'm going to strip back. That will go to the green screw here. The white wire will go to one of these silver screws, and the black wire will go to one of these gold screws. So this is 14 gauge wire. I'm going to strip it. Oh, and the way I'm going to attach it to this is I have some ring terminals, which I will crimp onto the ends of the wire, and then I will remove these screws and screw these down. You could also use a spade connector or fork terminal. One other thing I should point out is that this wire we will feed through the electrical box. You can just hit these tabs on the back with a screwdriver and they kind of pop out. They're kind of just bent forward right now, which will work fine for what needs to fit in here. It probably would have been easier to run the wire through first, but here we go. Got it in there without messing up the wires too badly. Good. And so now I will be crimping these ring terminals on. And these screws are a little hard to remove at the end. That's just so they don't easily fall off of this outlet, but they can be removed all the way. If you don't want to remove them all the way, you can use a spade connector instead of a ring terminal. A little bit harder to get back on right away, just because the end, like I said, it's to keep the screws from coming out. And you just want to look over your connections and make sure that everything looks flat and solid. Basically, this is going to screw into my box, and then we'll screw the box into the wall. So right now I'm about to hook up our GFCI outlet. The reason you want a GFCI outlet is you're supposed to use them in places near water. You've probably seen these before, they have little buttons in the middle. The reason you want to use a GFCI switch is if there's a fault, this will trip and you won't shock yourself. You can install a GFCI outlet at the beginning of your run of outlets, and that will protect the entire line afterwards. So we have two runs of wires, one on the driver's side, one on the passenger side. This one I'm going to be putting up on the wall right behind me here. It'll be right near our sink area, which is a wet area, but it'll also protect our other outlet. We only have two on the driver's side, so it'll protect the other one that is further down at the far end of our kitchen cabinet that I already installed. So yeah, I'm gonna go ahead and get installing this. It is a bit different from installing the other outlets, so make sure you read the instructions that come with it. So on your GFCI outlet, you'll notice on the back here, there's this sticker, and that covers this bottom screw on both sides. So you have your line screws and your load screws. So basically for your line screws, both your gold and your silver, this is for your wire coming from the power distribution to the outlet, and then the bottom one with the sticker on it, those go out and continue to your other loads. So if you're just installing one of these without any other outlets in parallel afterwards, you would only connect your wires to these top screws, and that would be enough for that. But since we do have an outlet afterwards, our wires coming from the battery bank is going to these top ones, and then I'll remove this sticker and wire the wires to our other outlets later on. There is only one ground terminal on your outlet, so I've just made a little pigtail wire. I had been using ring terminals on our other outlets, but the ring terminal won't fit in this device. The way the plastic is around here, it won't fit on here. So normally, if you have solid wire, solid core wire, you could just wrap it around. And so that's what I did with our stranded wire. You just kind of have to twist it all together, and then you wrap it in a little U shape and tighten the screw down on there. And then this I will put into a lever nut to connect to the other two green ground wires coming in from our line load and out to our loads. I gotta punch some of these in on my box. So here's my two wires basically. We'll have to make it into two. Okay, so I've taped one of my wires I'm not working on out of the way. First, I'm going to attach the silver screw on my line, which is the top screw here, to this wires. which are coming directly from our power distribution. So connect the white wire here. We could take our black wire, put that on the other side. And I'm just gonna connect all of our green wires so they are more out of the way. So here's my lever nut. Gonna be using it to connect the ground wires all here. All right, so now I need to connect this other wire. This continues down the line to the other outlet that we have. So that will be connected to these lower screws. So I'll take off the sticker, and the ground wire will just connect to the same lever nut as these other ones. And then we'll be done wiring this guy up. Okay, it's wired. So I just stuff everything back in the box and I'll screw it in. Great, there we have it. Just needs a faceplate. 2 tiny screws you screw in there. Voila. So now I'm just going to be wiring up one of these regular outlets, kind of similar to the way I did before, except for since this is in the middle of our run of outlets, so it'll have 2 wires. So it'll have the wire coming in from the line and then the wire going out to the loads. You do have 2 screws on here, so I could just connect the wires directly to those and then do the pigtail on this ground screw, but since it's not like the GFCI and it doesn't matter which line or load is going to which screw, I'm just going to attach pigtails onto 3 screws and use lever nuts to connect this. All right, I'm gonna strip these wires. So now I'm going to put ring terminals on these. Now that I have ring terminals on, I am going to attach these to their respective places here. That's the green one to the green screw, the white wire goes to the silver screw, and the black wire goes to the gold screw. So once you have your pigtails attached to the back, you're going to want to strip off a little bit of this other side, go into a lever nut. Okay, let's go wire it up. I am now pulling my wires into the box. Now I am screwing the box in. So now we just need to connect all the same colored wires with lever nuts and connect them to our pigtails on our outlet. Okay. Now we just add our outlet. Now those can all be kind of shoved back into this box. And then we will screw this guy down.
We also added an outlet here in our garage space in case we have to plug anything in our garage.
So I have this little device. I guess it's called a Snap It. I'll link it below. Plug that in. It's telling me if my outlets are wired properly. And right now it's showing just one in the middle, which means open ground. So I will look into that. But other than that, all the outlets are looking pretty good. This is our GFCI. And it's the same thing. It gets power, but it's just open ground. Upon further research, I found that it is okay for our outlets to say open ground. That's just because we are in a vehicle and not in a house. So that our ground is it's like a vehicle ground and it's different. So on those little testers, it's gonna show open ground, except for when we connect to shore power, then it should say that everything is good and grounded. So once we get a shore power adapter and we can plug the van into shore power to test that, then I'll test all the outlets again.
Hello from the future. Welcome to the lessons learned part of our video where we go over what worked, what didn't work during our installation, as well as how it's all going now that we've lived in the van for almost a year. Coming up in a couple months. So the first thing that we want to mention that we didn't show in the video was setting up our inverter charger for our battery needs. There's just a little screen there and some buttons that you need to go in there and make sure you have it set for your particular type of batteries. We have lithium-ion batteries, So that we set ours up for that. So just check the manual and it'll tell you exactly what you need to do for your battery type.
When we plug in the shore power on our battery monitor, it says we are charging 60 amps per hour, which means we can fill up our battery bank, which is 200 amp hours, in just a couple of hours. We rarely need to plug in because between our solar and our alternator charging, our batteries are topped up.
The last thing on our list today is to talk about the 120 volt outlets. As you saw when I was installing those, I did struggle a little bit with the ring terminals. If you have the option, I would suggest just buying the spade terminals, because then you would not have to take those screws all the way out, or potentially you could skip wrapping the stranded wire around the screw. This will just be a little bit easier. I only used ring terminals because that's just what we already had on hand. Didn't feel like buying a new thing. So that concludes this video. Thank you so much for watching. Please give this video a like and subscribe to our channel. We will be coming out with new videos every other Sunday, every other Sunday, on Sundays. We will be coming out with new videos on Sundays, so thanks for being here.